Tēnā koutou katoa, ko Maxime ahau. Welcome everyone, I'm Maxime. I'm a data scientist at NeSI and also a data science engineer at NeSI, and it's my great pleasure to present with Nisha Gatak today a lightning tour of dashboards in Python. So Nisha, if you want, I will let you introduce yourself.
Sure, Kotu. Good morning, everyone. I am Nisha. I'm the training lead at NeSI. My only job is to facilitate this event. I do nothing, no contribution in terms of the content. So thank you, Maxime. Just taking you through some quick, housekeeping notes. Please note that this webinar is being recorded. Do make sure to mute your microphone so that we minimize any sort of disturbance from the background. There is a Google Doc that I'm going to put onto the chat right now. We're going to use that talk to record any questions or comments you may have during the course of the webinar. I will be monitoring the document just so Maxime doesn't have to be interrupted while he's presenting. So I'll keep an eye on that. If you do want to pop in any questions on Zoom chat, please feel free to do so. I'll keep an eye on those too. And please do turn on your cameras if possible, just so Maxime doesn't talk to a bunch of empty screens. So over to you, Maxime.
Thank you, Nisha. And it's up to anyone's personal preference to turn off their camera, but I like to see the face of people when I do lame jokes. Okay, so a bit of advertisement before we start. I'm at NeSI, I'm part of the consultancy team, and if you're not aware of what it is, we're a team of research software engineer and data science engineer helping people to run their code better and faster on the HPC platform. And so we can help you to write some workflows, parallelize your code, port some code on GPU, rewrite some algorithm to try to make them more performant. We have a lot of case studies published on the NeSI website if you're curious about what sort of typical things we do. And if you want to get in touch with us, you can always contact us by emailing support@nesi.org.nz. Know that our help is usually free, but for a limited amount of hours if you are part of the collaborators of NeSI or if you have a merit-based allocation. Thing is save the date. So there are a couple of coming events that we'd like to make you aware of. First one is in 2 weeks, there will be a Machine Learning 101 workshop, which still has few seats available. And if you're interested in joining, you can always join the waiting list because we always have some people that can't attend at the last minute. So there may be more free seats. Early September, there will be the HPC Australasian GPU Bootcamp, which is co-organized by NCI, POSI, and NeSI. It's more targeted for C and C++ or front-end developer to learn about CUDA and OpenACC. And finally, very important, also early September, there is the Nzrc Conference, New Zealand Research Software Engineer Conference. Registration have opened, and submission, well, they're not open, sorry, that's a mistake in my slide. They will close on the 5th of August. So please don't hesitate to submit a talk or a demo or a lightning talk you want to have at this conference. And in case anyone thinks this is HPC specific, no, it's not. It's research software engineer specific, and it's a technical conference. I attend them every year and I really enjoy it. So if you like this sort of content like today, that could definitely be something at this sort of conference. This being said, a bit of introduction about this webinar and how it has been thought and created. So for today's webinar, it will be more sort of show and tell. So sort of my journey through discovering some Python packages to create dashboards. And it started by me scratching my own itch and trying like, okay, there's a lot of packages. I want to understand what each of them are doing. Is there one which is better than another? Or, well, usually you don't have one better than another. Usually you have different use cases and corner cases. So I wanted to have a bit more understanding about this. Also, you can combine them, so it's nice to know how they can interact with each other. And I had actually a goal for myself, which was I wanted to create a small internal dashboard for NeSI. So, and I like to have this sort of goal-driven learning. So it was a pleasant journey. And so what I try to share with you today is what I've learned along the way. And it won't be a deep dive into one technology in particular, but a tour of what exists and what I've seen from each of them. Yes, a word of caution. I'm not an expert in these packages, so some things I may say may be wrong or inaccurate. And so if someone is more knowledgeable than me in the audience, please don't hesitate to comment in the chat. I think everyone will benefit from this. And also these packages, they tend to evolve quite quickly. So if you're looking at the recording, or even if I'm not up to date as of today, some things that I will say or comment on may be wrong in the future because they change quite quickly. Finally, two more things. It's absolutely not HPC centric in case some people had these assumptions. What I will show today can run on your laptop, on your workstation, anywhere. Of course, you can also run it on the HPC, and that's what I will be doing today, but that's just because I have the chance to have access to this platform. And it's Python centric. I'm aware about R-Shiny, but we won't be discussing R-Shiny today.
Python Shiny, Python Shiny.
Yeah, okay, maybe we can talk about this one later. Okay, so that's it for this. Next, so I will do everything in just to be sure, do you all see the Jupyter notebook? Yeah, okay, great. So what I'll present today is I will walk through a Jupyter notebook. It's in a publicly available Git repository. You'll have the link in a later email. Also, you have it in the QA document. And okay, and to start, let's have a look at a typical example of a dashboard. So I'll reuse something which is provided online and which actually display some data about glaciers. And I want to highlight what will be my definition of a dashboard, at least for the scope of this webinar. So in a dashboard, you'll have a couple of things. Of course, you have visualization of your data. So you have a couple of plots. What is nice usually is the plots are themselves interactive, so you can zoom in and out. But what makes a dashboard particular is you usually can bind the different plots together. So for example, in this one, if I do a selection, here you have a small spinning wheel that indicates you that something is being computed. And here you see that what I've highlighted, so these glaciers that I've highlighted, will create a selection, and my histogram in these two panels, and actually in this scatter plot too, they are related only to this subset of the data set. In this particular example also, there is a cool technology which I will just name but won't go too much into details. It's called a data shader, and it's a cool technology to offload some of the computation on the server side. So the the client-facing parts, what is running in my web browser here, don't have to display thousands or millions of data points, but just an image which has been prepared by the server. And when I zoom in here, you see it's a bit blocky, but actually the web server will recompute a new image and it will send me here, you see an updated image. So that's one way when you want to scale to extremely large data sets. But again, that's a bit out of the scope of today's talk. So you have these sort of things, and the last type of elements you will have in a dashboard are buttons and widgets in general, sliders. Here we only have one, which is clear selections, but you of course can have many more, and that will help you to sub-select your data or show different views of the data. Okay, so that was an example of a dashboard. Before we look into the code, because I will show you some small snippets of code just to give you an idea of how complicated or easy some of the toolboxes are, I have a few more words I wanted to say. So we've covered roughly what is a dashboard and what are the typical use cases that you may feel like it could be a nice thing to have a dashboard. The first one will be maybe you want to share some visualization with your colleagues, because if you don't want to share the visualization, maybe a notebook is actually just enough for what you want to do. But the cool thing with a web app is you will run it on your computer or on a server, and then you can give just a URL, so a web address to your colleagues, and they can have a look at the same data as you without having to install anything. And that's maybe a way to lower the entry barrier to have a collective look at some data. Maybe you also want to share it on a wider audience, which means actually on the web. So it will be not only on your internal network, but also facing the web, which have other associated challenges also. Another nice use case, in my opinion, is to monitor systems. And when I was talking earlier about an internal dashboard for NeSI, this is typically, I was experimenting with some internal monitoring systems. So dashboard was very practical for this. And the last use case is, let's say you have some, I don't know, huge data set that are sitting on a remote platform, and you want to see the results of your simulation or computations. If you have a web-based display, well, actually, you don't need to retrieve the data locally to display, but you can access the dashboard and the data stays there on the distant server, and you can just play with it. So that's also, I think, a nice use case for the dashboard. However, a few words of caution. I really find dashboards cool, but it's like every tool, it's nice to know when it's the right tool for the right job and when it's a bit overkill. The first thing is, well, we should not forget that if you're processing some data on your local machine, you always have access to a local GUI, and so maybe it's just fine for what you want to do. And even if the server is not so far away, you can do an SSH connection with an X display, and that can work just fine. Something I tend to forget personally is our beloved Matplotlib library. Okay, it generates images if you're working in a notebook, but if you're not working in a notebook, or if you install some extensions, they're interactive plots, so they actually to play with your data, it can be just fine. If you have very high number of data, there are some specialized libraries which also will work locally on your machine. And one I like to mention is Napari, which is very cool for that. And you have some software like ParaView that can also help you. And finally, the dashboard comes with one more complication, well, one more problem, which is you need to have a server, so somewhere where it will be running. Maybe what you want to share some interactive plots with your users, stakeholders, and for that, maybe an HTML page with some interactive JavaScript plots will be just enough. And that way, you can serve them as static pages. So you can put them on GitHub pages, for example. So it's nice to do that, to keep in mind this alternative, because sometimes they will be just fine for what you want to do. And if you want to deploy your dashboard, just keep in mind who will pay for the server, how you will scale if you have more users, how will you deal with authentication if you want to share it outside of your own institutions, and make sure also that your dashboard sits in a place where you can access the data. Because sometimes in some places, for security purpose, you will have different networks, and your storage may be sitting in one network, and maybe the user-facing server will be on another network, and they can't talk to each other, and that will be a problem for deploying your dashboard. Okay, that was pretty long introduction. Sorry for that, but I thought it was important to remind these couple of points. Okay, so let's try to create some dashboards. So what do we need to create the dashboard? We need, in my opinion, two main ingredients. The first one will be the plotting libraries, and especially you want to have interactive plotting libraries, so plotting libraries that will create some JavaScript code somehow, so you can actually zoom in and out and play with your plots. And you also need what I would call more a dashboard library, which will implement all the widgets and callbacks logic. And so here I've listed a couple of options. We won't look at all of them today, but of course, for plotting, sometimes the static, well, the vulnerable Matplotlib and some higher level API like Seaborn can be just fine. Also pandas.plot and xarray.plot, so the plot methods are very nice too. For a long time, I ignored the pandas.plot, and that was a shame because actually it's very good and you can get a lot of things done with just this one. Of course, this one is not very interactive. So if you want a bit more interactivity, you can use Plotly. And again, so here I've organized this in terms of level of the API. So on the left, you have sort of the lower level when you really want to play with the glyphs and the markers. And when you go through the right is higher level API. So you provide data, and then you just tell it, I want to plot this column with this column and do it for me, please. So Plotly Express is the higher level API of Plotly, and it's quite nice. And you can use data shader for larger data sets. Another toolbox we'll spend a bit more time talking about, because this one I became a bit more familiar with, is this Bokeh HoloViews HVPlot stack. So Bokeh will be a JavaScript and Python library to do the plotting, and these two will be a higher level layers. The last one is a very interesting one. So Vega and Vega Lite are JavaScript only libraries, so they're not Python library, but Altair is a Python package that will actually generate this code. And if you use this toolbox, you can generate very interactive plots compared to the other ones, which are JavaScript only. So you don't need a web server. For the dashboards one we won't talk too much, well, we won't talk about today, but it's good to be aware of, is the Ipi Widgets, which lets you create some tiny widget sliders or buttons within the notebook. The two will have a look at our Streamlit and panel, which have some different trade-offs, let's say. One, unfortunately, I don't have the knowledge about, but if anyone knows about it and want to comment in the chat, I will be super happy to hear some feedback about this one, is Dash, which comes more from the Plotly community and is well integrated with it. Yeah, that's one I did not investigate too much into, but doesn't mean it's bad. It's another solution. Okay, I'll just pause for a second and ask if there's any question or comment at that stage.
Please feel free to either use the chat function or the QA doc if you have any comments or questions.
Okay, so let's get started with the code, as it seems there's not, except Mike, who's very enthusiastic about Bokeh. Okay, so just as an illustration, I'll use the dataset I really like, which is the Palmer penguins dataset, which is a tiny dataset about 3 species of penguins that happen to live next to the Palmer station, and this data has been collected and made available by Dr. Christine Gorman. And it's a typical dataset which you can use for data science, machine learning intro workshops. So I'll load pandas and use pandas to load my dataset. It's provided as part of the repository, and we'll see what it contains. So we have some tabular data with the species of the penguins, the culmen length and depth, so the beak, if you want, length and depth, the preferred length, and the body mass, and if it's a female or not. And now the goal will be to visualize this data and have different views of it. I'll start with a Seaborn example, because even if, as I said, it's not interactive, sometimes Seaborn can do pretty advanced plots, which can be just fine for what you want to do. So first thing is, as always, we import the toolbox. Seaborn.set will set the style, and what I really like with Seaborn is out of the box, it has very good-looking styles. Now Matplotlib has it too, but for a long time, I would prefer the Seaborn one. So I'll run this one and I'll explain what it's doing, which probably will be pretty obvious. So this one is what I would call a sort of a high-level API type of function or method, where you provide the data to this function. So you say, okay, my data is this data set. And then you instruct Seaborn about what will be your different coordinates, what you want to plot on the different coordinates. So for my x-axis, I want the culmen length. Y-axis, I want the body mass. Hue, so the different colors, I want the species. And actually, I want to facet my plot. So the different columns will be if it's a female or not. And the type of plot I want to do is a rel plot, which is a relational plot. By default, it will be a scatter plot, but you can have other type of plots. And in just one function call, I already have something which is which could be considered pretty advanced in the sense that if you want to do the same thing directly calling matplotlib, you will need a bit more code, and maybe it won't be as nice looking out of the box. So what is interesting here is this sort of high-level API. We'll see it again in the other toolbox, which is always you give it as an input, a data frame, or some other type of data structure that has the knowledge about what are their dimensions, and then you just tell what are the dimensions you want to plot against each other. And as a last note about Seaborn, usually I use it as when I explore data, and if I don't have a good reason actually to start having stuff interactive, I will start with Seaborn and do a lot of facet plot to have many views of my data. And that can be sometimes just good enough. I save that as a PDF and I can have a look at it later. Okay, the next one will be Plotly Express. So please ignore this little one because it's just a temporary glitch we have on the platform. Yes, I did not mention, but the whole thing here is running in the Jupyter hub, running on NeSI, but again, you could run exactly the same on your workstation. So here I'm importing Plotly Express, and very, very similarly to Seaborn, we'll use a scatter function in that case, give it the data set and instruct how do we want to plot the data, each of the dimensions against each other. And let's do this. So as I mentioned earlier, it's based on Plotly. It creates an interactive JavaScript code. As far as I know, it prefers Pandas data frame, or I think the Plotly Express one, you do need to have something which looks like a data frame. Something I've discovered, and this is where, don't take my word for it, because maybe I've not explored the API well enough, is Plotly Express lets you create full features figures easily, like here in one line of code, but it does not, at least in my opinion, does not interact very well with the lower API of Plotly. And for me, it was difficult to start a figure with Plotly Express and then tune it or tweak it a bit so I can get what I want by using the lower API, which is what I tend to do with the other toolboxes. Is I start with the high-level API to get almost what I want, and I use a bit of the lower API to adjust it to my needs. And here, okay, so something we'll see also with bokeh and hollow views is here you have these interactive plots. When you hover on the glyphs, you can have more details about the data. Underneath, you can zoom in and out. Oops, sorry. Let's see if I can zoom in. So you can zoom in and out, and the cool thing is also it will link the axes for you. So here, if I move one of the two plots, it moves the other plots. So that's a very good basis if you want to do a dashboard. Okay, next contender, hvplot. So this one is, I'll spend a bit more time on this one because again, as I said, I know a bit more about this one, and it's a bit more complicated in my opinion, but for good reasons. So here we have a lasagna of APIs. So hvplot is on the top, but actually it will sort of prepare the job for the middle API, which is hollow views, which itself will delegate the plotting to bokeh. And here, if I want to say a few words about hollow views, what it does is you take your data, let's say your NumPy multidimensional array, you annotate it. So you say, okay, dimension 1 is this type of data, dimension 2 is this type of data. You can give it coordinates. So you sort of prepare your data and annotate it. And then you tell hollow views what are the dimensions you want to plot against each other and which sort of glyphs. Exactly what we've seen before. What hvplot brings to the mix is the idea is like, okay, but if you have a pandas data frame, or if you have an X-array data set, sorry, that's a typo, or data array, or if you have a Dask array, sometimes you already have this information about what are your dimensions. So you don't need to re-annotate it by yourself. So hvplot will sort of simplify this. How do I ingest the data frame or other things to hollow views? And also hollow views is like a Lego box. You have many small components you can bind together, where hvplot is more like I give you one big function with many parameters, and that can give you a lot of things out of the box. That's actually my take on this toolbox and how I understand the interaction between the two. So usually I start with hvplot, which gives me almost what I want out of the box, and then I will use HoloViews to adjust and change. So here I'll just import it. Interestingly, when you want to use hvplots, you import it for the data structure you want to play with. So here I want to use it on the pandas data frame. And my pandas data frame, which is the set here, will have a new method, which it did not have before. I'm not exactly sure how they do this, if it's some sort of monkey patching or something else, but it adds a new method, hvplot, which I can use to do the plotting. So the same as you would do dset.plot if you were using the normal pandas API, now it will use dset.hvplot. And same story as before, you can say, okay, what are the different axes you want to plot against each other? In that case, I want the small difference here is I will say, okay, I want to plot by if it's a female or not, and I need to specify I want this as subplots, so I have them side by side. Otherwise, it will actually give me a slider or a drop-down menu. And you can also pass a large amount of other properties directly at that stage. And here, similarly to the Plotly case, you will have linked plots. So when you move one or other, it's aware of the fact that these two axes are linked, are the same. And you can zoom in and out, and you can hover the data, and you get some more information. Okay, but just as an illustration of how would you interact with HoloViews? So again, this API which sits right below hvplot, I'll create the exact same plot, but with multiple steps. First one is I will subselect my dataset just to isolate the male and the female components of the dataset. I will use hvplot just to create two figures, two small plots. So this will be this HV male and HV female objects. And here start the fun, because we have, at least for me, we can use sort of, I think the right term is the grammar of graphics sort of combination of plots, which is likely familiar to people using ggplot, I think. But it was very new to me, is if you use a plus between your figures, it will put them side by side. If you use a multiply, it will layer them, so it will put them on top of each other. And with this, you have a very powerful way to combine your different figures without having to mess with subplots and things like that. So if I run this one, you see that I have my two plots side by side that have combined with a plus. And then again, I keep the interactivity. Bonus point with HoloViews, it has this options method. So if you take a figure that you've assembled, which again can be just one plot or many plots layered together or side by side, you can say, here are my options. And within these aggregated figures, let's have a look at everything which is a scatter plot. And for this one, I want to change the properties, and I want to have the legend and bottom and the show. I want to show a grid. So that's sort of a way to adjust the style of your plot at the high level. I find it's quite elegant. Okay, and we'll reach the last one, just checking if there's any comment or question at this stage. And also don't hesitate to tell me if I'm going a wee bit too fast.
No questions as of now. So.
Okay, cool. So let's dig into Altair. This example will be slightly more complicated. So as I was saying, this one is actually provides a Python API to a pure JavaScript libraries, and has a nice one-to-one mapping. So for people that like sort of how it has been made, they auto-generate the API of Altair, parsing, I think, some of the API of Vega, which is quite cool. And their approach to making graphs is quite interesting. They decomposed, instead of having one big function, as we've seen before, that try to do a bit of everything. They decompose in multiple steps. First, you ingest the data. Then you decide what will be your marker. Will it be a circle, a line, a bar, a rectangle? Then you decide of the encoding. An encoding step will typically say, okay, this is the dimension I want to associate with my X, Y, row, or columns. And next, you can also change the properties. The very nice thing with Altair, it's not too complicated. I won't say it's super simple, but it's not too complicated to create some interactivity between your plots in a way that when you finally save your figure, it will be kept in the JavaScript. So you code everything in Python, save it, and you have a nice JavaScript-only plot. But the best way to explain this is to illustrate it. So the first thing I was talking about here, again, we see the very same plot as before, but you see these different steps of, okay, I'm creating a chart. So here I'm ingesting the data, my data frame. I will say, okay, now my glyph, I want it to be circles. And the encoding, I want the X to be the Kalman length, the Y to be the Kalman depth, colors to be species, and columns to be, is it a female or not? For each of these dimensions, you can actually enhance them and add a lot of other options. I've just done it for X and Y here, where I say, okay, for the scale, I don't want to include 0. Otherwise, by default, it will include 0 in the scale. So that's how I turn this one off. And here it is, I have my interactive plot. Something which was not straightforward for me out of the box, and still as of today. The other toolboxes we've seen, they have some tools that you can activate and deactivate if you want to do selection or if you want to do zoom in and out. This one does not have this. So depending what you want to do, it can be not as good as the other ones. But here's the cool thing. What if, so this one is a slightly more complicated example, so I'll run it and explain after how it does it. So I've not saved and reopened the figure, so you'll have to trust me on this one. But here, what I've done is something where if I select a part of my graph, all the plots of the dots which are inside are increased in size. All the ones which are outside are set in gray and decreased. And the histogram, the marginal histograms, actually are just following what is in the box, right? And all of this is JavaScript code, but I'm not a JavaScript coder at all. I didn't have to write any, so it makes me quite happy to be able to achieve that with only Python. So let's have a look at how this has been done. So the core of the plot was this scatter plot, and this is this one, which is almost the same as what we've seen before. The change is I've created a brush, so to create this rectangular selection. And here I add a condition. So for the colors, I say, okay, the color is conditional on the brush. If it's selected, you show the species. If it's unselected, so outside of my box, you will use a light gray color. And then I do exactly the same thing for the size, saying that if it's selected, a big marker, and if it's unselected, you have a small one. And then I add the brush to the chart. So that gives me the central part. And then it's the same story for the two marginal histograms. So here we see a different a different glyph. So here I say this will be a histogram, so I want bars. And the way I will encode them is for my X, I will bin it. So I create bins. That's how you get an histogram, basically. And for the Y, I want to have the counts of the number of data points within each bar. And the last secret element, element of the secret sauce, is this transform filter, which associates the brush. So the data which has been ingested in that part of the chart will be sub-selected based on the brush. And that's it. Having this, I'll redo the same for the one on the side. I have all the elements I needed to create this interactive plot. The last bonus point is, again, similarly to what I've shown you with hvplot and HoloViews, this one has a sort of a grammar, a syntax to combine graphs and in the following way. So the histogram depth is the one you see on top. Then I've used this n sign to say everything after will be bottom. So this part of the figure is everything which is in between these parentheses. And then within the parentheses, chart points is the central one, vertical bar means, and the next one will be on the right. So in this one line, actually, I've created my layout for this figure. Okay, so how are we doing in terms of time? Okay. I'll just show you this one very quickly, just to as a teaser, let's say. If you go to their documentation of Altair, I really recommend having a look at the exploring Seattle weather. They show in details how they build this plot, and here's the resulting plot, which actually put a lot of information within just one plot, which is quite nice, a nice achievement in terms of visualization. And also they have this sort of interactivity where you can sub-select and update live histogram. And here, all of this is static, so they don't have a web server in the background to have this running for you. Okay, but I guess I've attracted some of the people here by talking about dashboards, so maybe now it's time to switch to the dashboard part, not only to the interactive plots. So the first thing we'll have a look at is Streamlit. So Streamlit, I think it's quite a new contender in the space of dashboards in Python. And it has very, very cool and very interesting properties. The first one is, if you're familiar with writing GUIs, regular GUIs, desktop GUIs, you may expect that you have to create your widgets and put them in the layout and bind callbacks or signals. And I'm not so familiar with doing this, and usually for me it's a bit of a pain because I don't manage to organize the logic very well. However, I write most of the time scripts that do the following. They take some data, they do some processing, they save the data. That's sort of my typical type of job. And what I like here is I can write a very similar type of scripts and it just works. The way it works is because they will use your script. You will tell where are the widgets, but for the logic in the script, you can assume that you just have the value right away. And I'll explain that in a second. And then the command line interface tool, so the Streamlit command line interface tool that you point to your script, will just keep reloading again and again and again your script every time you change a widget, which may be perceived as not super efficient. That's why they have a lot of logic around caching. So you can cache the time-consuming part of your script. So when you move a bit a slider, the data loading, for example, is not recomputed. It's just cached. Yes, and they have, by default, they have a very nice layout in terms of website. I'll show you that in a second. And you can reload live your code, so you can change your code, rerun, and if there is a problem, you'll see the stack trace in a way which I believe is quite interpretable. Okay, so just to explain a bit of the details of how it works. So here, this creates a separate script here. And here is just because for this webinar, I wanted everything to be in a notebook, but typically you would create that in an external editor. So I load the data. First, I will use this write function. And the write function is a bit of a magical function in Streamlit, in a sense that it will take whatever you give it to it and find a way to display it in an HTML page. So here I've give it text, well, actually text with a penguin emoji, and it will find a way to render that. Then I give it my data frame, what is the head of the data frame, and it will find a way to make it a nice table. Then I create some widgets. So I create a side box, I create a selection box to say what are the columns I want to use. And actually I indicate I want them in the sidebar. So that will influence the layout. And I also made a checkbox for is it a female or not. But here, even if this by Streamlit will be interpreted as create a widget, when I write this code, I can assume that X here is a string. It's actually the value which has been selected, which means the rest of my logic, I don't need to care about the widget anymore. I just focused on, okay, if X is equal Y, for example, I want to create a figure which will be more a kernel density estimation figure, and otherwise I want a scatter plot. Then I have my figure and I wrap it into the pyplot function, which make it nicely displayed on screen.
Maxime, there's a question if you want to take it now.
I'll just run this one and show on screen what it looks like, and then yes, we'll do this. Oh no, actually, let's do the question now.
It's on the Google Doc. Mike says, for Streamlit and its live reload feature, does it retain any existing data in the plot or scripts, or does it start from the beginning each time?
That's a very good question. I think it would restart from the beginning, and that's why you need to have the caching. This is where I've not explored enough this toolbox to answer that one, but I would assume that it tries to restart from the beginning, and that's why you want to have the caching in place. Okay, so here I've started. So this is running from a command line, so that's why there is this exclamation mark. This exclamation mark sign at the beginning of the line, and I've pointed it to my script, and it has created a web application. Here, I won't go into the details of how this is achieved because it's recorded in another webinar of NeSI, but via a reverse proxy, actually, I will access the dashboard. And this is how it will look like if it renders. Should take a second. Okay, so here you see the widgets I've created previously. So the one I said are in the sidebar. So the sidebar actually can be collapsed and extended, and I can change what I want to show. And what you see is here, the central panel will be updated accordingly. And if you remember, or if you've seen in my script, there was this small logic, which is if I display the same X and Y, then actually you don't do a scatter plot, but you use something else. Here I've also added another widget, but this one I've not put in the sidebar, so that's why it's in the central area. And as I said previously, we can have our little penguin emoji, and we have a nicely displayed table. And here, because I used Seaborn as the plotting, this is not interactive, but I could have used Plotly or HVPlot, and then I would have or Altair, and I would have an interactive plot here. Let's see. Okay. Hope we won't run out of time, but I want to show you what happens when it crashes. So I will inject my favorite errors, which is 1 divided by 0. We go back to the dashboard, and here you say, oh, source file changed, rerun. Yes, sure, let's rerun it. And here you have your stack trace. And the fact that it's not, maybe it will be taken as a given for everyone, but sometimes you have some toolboxes that it will just crash, and it won't be crashing, in the web page, but it will be crashing in your console where you've been running the code. So you will have to go there and have a look there. Maybe it's in a different panel or a bit hidden. So this is a simple thing, but I really appreciate is they make the error very visible and easily accessible. And if you solve it, you don't need to restart the whole thing. You just restart it, and now it works again. So just in terms of ease of developing your code, I feel like this is well thought. So my opinion about this one is very nice to get started. If you want to have, a little bit of widgets to interact with your data, have different views, it's great. The thing which, again, because I've probably not explored this enough, but the thing I've not found is a nice way to have callbacks, which is their trade-off. I mean, you don't need to have callbacks, but they don't seem to be easily accessible. So if you want to create one plot and make another plot react according to one plot, things become more complicated. But maybe this is beyond the use case or the typical use case. Is there anything else I wanted to say about Streamlit? Let's see. No, I think that's it. Okay. And if you're running this notebook, or later if you're running this notebook, note that this one is blocking the application. So we need to stop this one before we proceed to the next part. Okay, we have 13 minutes to cover panel. That will be hard. So panel is actually my favorite one, so probably I should not have put that one at the end. What it does, it gives you a lot of building blocks for your dashboard. And one of the building blocks will be what they call the panels, actually, which is a way to wrap any sort of Python object, and they have a large collection of wrappers to expose them interactively in your web application. And of course, you can think about how do you wrap a plot, but you can also expose a table, Markdown, a PDF, video streams, even VTK objects. So you take your objects and you call the wrapper object in panel, and once you instantiate your dashboard, it will be displayed and rendered in the interface. That's a first very cool thing. But it's cool to have panels, but how do you organize them? I have a bunch of functions, or more objects actually, to organize your different elements into rows, columns, widget boxes, and they have spacers, so you can have an elastic can stretch the distances when you change the size of your web page. And the last and very important part is the widgets, because you want to have some interactivity. So you want to have sliders, button, date picker, so they have a whole collection of them. The last part, which can be a bit confusing, at least it was for me, is the API is very rich, and they have made a lot of different ways to bind your plots with the widgets. They have a very high-level API, which does almost everything for you out of the box. You annotate a function, and it creates even the widgets. And you have a very, very low-level functions and methods where you do all the cobys manually. I'm not a huge fan of these two extremes. I really like the one which are in the middle, and that's the one I will show you today, which is the binding approach, where you take a function which is supposed to generate a panel, so something you want to show on screen in the HTML page, and you bind it to a set of widgets, and it will return a panel that you can use in your dashboard. And that's where you have interactivity. If this wasn't clear, I'll illustrate that, and hopefully it will be less unclear. So first I will load the panel. And for this one, what is cool is compared to the Streamlit, which I was actually creating in a separate script, this one I will actually create it in the notebook, and yet I will deploy a dashboard. So here I have my drop-down selection menu for the Coleman lens. For the x-axis, same for the y-axis. I want a checkbox for females, so I'm creating my checkbox, up, nice. And let's add a slider actually for the size of my glyph. So here I've prepared all my widgets. I will create a small plotting function that takes some inputs, which, well, not surprisingly, the inputs are what are the X, the Y, is it female or not, and what's the size of my glyph. And maybe I need to execute this one. And next is I will assemble all of this and have a first sort of mini dashboard. So what I've done here is first, I've organized my different elements in the following way. So I've created a row. So every element in this function call will be placed one next to each other. So I have, yes, so I will have this one here and then the binding here. And then I create a column. So each element will be placed one above the other one. So here I've placed all my widgets in a nice column. So that's this call. And the last one is the one I was referring to previously, which is this call of the bind function. So I'm binding the plot function to all the widgets. And that way now, if I change a bit my slider, I can change the size of my marker, I can change what are the inputs, right? If I can scroll just a bit up, what is kind of cool, in my opinion, is all the widgets are actually the same within the notebook. So if I change this one, you see that this little guy here is also changing too. So they're the same. And if it goes even further than that, so here I have my assembled panels, my dashboard. And what I will do is I will serve it. So now I'll say, okay, you will start a web server, and you can access it and have it as a dashboard. So now I'm not anymore in the notebook, even if it's running on the same process as the notebook, but I have my externally accessible dashboard which runs the same. And you can start thinking about a workflow here, which is you create your notebook, you serve it, and then you give the URL to your colleagues, and your colleagues don't need to play or mess with your code. They can actually just access this and have a play with it, right? So now I'll stop this one. An option I want to quickly mention is If you like the same thing as in Streamlit, which is you don't want to care too much about how you place your widgets, you want something which looks good out of the box, there is a templates option. Well, there are multiple templates where you give it a main area and a sidebar for your widgets. And here I'm just using it and serving it, and ta-da, we have actually something which out of the box looks a wee bit more professional. So that's quite nice too. I'm just thinking, yeah, I think that's what I wanted to share. The last part is, okay, that's all good, but what if you don't want to use a notebook, or if you want to have something which you don't need to run a notebook to provide it to your colleagues? So I'll write another script, which is exactly the same as what the thing I've been creating in different cells. The only tiny difference is the last object, the one I want to serve, I will call the servable function. And with this, I will use the panel command line tool and give it the scripts. It will run it, and it will look for whatever has been marked as servable. And if you do this, then you have your dashboard deployed. And this one have a lot of options, which I'm not all aware of what they are doing, but typically it will handle scaling up, for example. So if you have more people, you can start to spawn more processes and scale up in that case. So if you want to deploy your application, that will be the way to go. It's not the one where you run a notebook is really a nice way to quickly share things with your colleagues, but that will not be the way to deploy your final dashboard. And here again, so this one is the new one I'm serving is the one I'm showing now. Is there anything else I wanted to say? Yes, very important point about panel, the last cool thing before we close. Here I've been passing a script, right? And as I said, it will take anything which has servable at the end and show it in the web app. You can do it the same with a notebook. So you can take your notebook, and if at some point you put servable, I've not done it here because this notebook has a lot of other stuff because I've been presenting other toolboxes, but if I were to use only panel and in this notebook, I could feed it the notebook here and it will be served as an application. So you can think about a nice way to have a quick trial and error and experiment and deploy your dashboard, which is you create everything in a notebook, you tag with servable, you use panel serve, and bam, you have something you can point to your users or colleagues to. And that's it for this lightning or whirlwind tour of the of the plottings. I don't know if there's any comments or remarks at that stage.
In the question doc, I think it's something that you mentioned, but do you want to go through it again, about the plots from the Streamlit?
Yes. So it's exactly, so what the person says is the plots from Streamlit seems to be static. Indeed, they're static because in the example I was using Seaborn. So it was just displaying images. If I would have used another plotting tool, so like Altair, HVplot, HoloViews, or Plotly, then there will be no issue and you would have an interactive graph at that stage.
Couple of more questions being typed in right now, but while they type, well, I think it was James who mentioned that. Do you have any thoughts about other options on when we talk about dashboards?
I know that this is, even if I'm trying to explore the space of dashboard and interactive plots, plotting library in Python, it's far from being the whole story. I think there is one which is called Voila, which I've not checked for a long time, so I'm not sure exactly what is it doing, but I know it exists. So there's another one like this. And then, of course, there are options in other languages, which can be good to know. Yeah, I'm not sure I have a lot more to say at that stage. Okay, do any of the libraries require subscriptions? Oh, if you think about paid subscriptions, everything I've shown today is open source. There's nothing, it's everything you can use and deploy on your own. I'm not aware, maybe I'm wrong, but I'm not aware if, they have a sort of, yes, okay. So the people doing Plotly, I'm quite sure that they provide professional support. So if, for example, you don't want to host the web app, the dashboard yourself, you can probably pay them and so they can deploy it on their infrastructure. But I'm not exactly sure for the other ones. I don't think so. Okay, another question is how easy is it to pass the selected data in the plots to a table? Yeah, okay. That's a good one. It will depend on the plotting. Okay, let me go back here. So what will happen is it will depend how your plotting library expose callbacks to sort of the dashboard library. I can't say for Dash because, as I said, I'm not very knowledgeable in this one. Streamlit was not super clear to me how to handle this sort of callback things. Maybe they can, but I have not found it. In Panel, what's quite cool is Panel will expose some callbacks which are specific to the different library, and it does support Plotly, Bokeh, and Altair libraries. And then you can use this callback to trigger something else. So that's a quite nice thing. Is it easy? Yeah, you need to browse a bit the documentation to learn how to do this. I see that we'll be running out of time, so I'll just conclude briefly, but we'll stay around, or at least I will stay around for answering any additional question if you want. So just to finish, again, you'll have this information in a summary email after the webinar, but the code is available on the NeSI GitHub. If you like this sort of events, let us know. Also, this sort of show and tell is a bit of a new experience, so we'll be very happy to learn from you if this works for you or if it's not optimal and it's not your favorite format. So if you have any question or feedback, there's only one email to remember at NeSI, support@nesi.org.nz. And of course, don't hesitate to join our mailing list to know when are the next events. And thank you everyone for your attention. Yep, that's it for today.
If you're waiting around for an answer on a question that you've popped into the doc, please do stick around. We'll get to you right after. Everybody else, please, you're free to go. And thank you so much for joining us.
Okay, so the remaining questions, let's see. So the subscriptions we've answered, selecting data, I've tried to answer. Which one of you is, in your opinion, more suitable for multi-users without interfering with each other? For the dashboard, I would say Streamlit and Panel will do a good job. They have been made exactly for this use case. So as far as I know, they should not interact with the same data. I'm especially more sure for Panel because that's the one I've been using. Because I know this one for sure will basically spawn a new instance of the dashboard for each of the user. Okay. Okay. Someone, I'm not sure who's asked also, in order to deploy a dashboard, we have to pay for a server. That's okay. So that's something I tried to point at the very beginning. It will depend basically where you work. The best thing is usually to contact your IT service, who will tell you what are the options, because there's many options. I mean, you can go with maybe the cloud, AWS or Azure or something like that. Maybe your university or CRI already has and probably has an internal IT team who's responsible for deploying services of that type, and they can provide you a virtual machine, but you need to contact them and tell them, hey, I want to use this. And they will very likely ask you, how long do you need to use it for? What are the characteristics in terms of CPU and memory you want? How many users are we talking about? How critical are the data which is accessed? Because maybe it's a security breach if it gets its leaks anywhere. So be prepared to be asked these questions. So that will be my take on this one.
I guess that's it.
Yay, cool.
Thank you so much. And if anyone else has any more thoughts, I guess we can stick around for 5 more minutes, maybe?
Yeah, no problem.
Thank you, everyone.